Mindy is happily playing on a swing. In part A of the problem, we are asked to use pie charts to analyze the energy storage and transformations of the Mindy plus swing plus Earth system at two different positions along her trajectory, at the highest and at the lowest point in her swing. Ignore air resistance. In part B of the problem, we need to write the conservation of energy equation for the system. The system is Mindy plus swing plus Earth, and it is an isolated system. The gravitational force acting on Mindy and the swing is an internal force because the Earth is part of the system. There are no external forces acting on the system, and as a result, the total energy of the system is constant. No energy is transferred into or out of the system. We need to consider two positions: state A at the lowest point in Mindy's swing, and state B at the highest point in her swing. We select the gravitational potential energy of the system to be zero on the ground. When Mindy passes through the lowest point in her swing, state A, the system has both gravitational potential energy and kinetic energy. The gravitational potential energy is energy stored in the position of Mindy and the swing with respect to the ground. The kinetic energy is energy stored in the motion of Mindy and the swing. We represent the total energy at state A with a pie chart that has two slices, one for kinetic energy and one for gravitational potential energy. As Mindy and the swing continue their motion towards the highest point in her swing, state B, Mindy gets further away from the ground. The gravitational potential energy of the system increases. Her speed decreases as the motion slows down from A to B. The swing stops at point B and reverses its motion. The system has no kinetic energy at state B. The total energy of the system at state B is made up of only gravitational potential energy. The size of the pie chart is the same because the total energy of the system is constant. All kinetic energy of the system in state A was transformed into gravitational potential energy in state B. For part B of the problem, we need to write the conservation of energy equation for the system. We know that total energy of the system is conserved. We can then write the conservation of energy equation as total energy of the system at position A equals total energy of the system at position B. The total energy at A is made up of both kinetic and gravitational potential energy. Total energy at B is made up of only gravitational potential energy. We can then rewrite the conservation of energy equation as kinetic energy at A plus gravitational potential energy at A equals gravitational potential energy at B.